Welcome back to our series. If you caught our last episode, we had a little excitement lifting these 3 big gable end walls and setting 8 beams. I don't know if you caught that, but it was something that I am very glad to have behind us and frankly relieved that it went as well as it did. If that was the first encounter you've had with our home building series, you might drop back a ways and recognize the fact that we started when this lot was nothing but grass and mud. That was quite a while ago, and we've come a long ways. There is a lot of good information about site prep, due diligence, what escrow is, what easements are, just a lot of things that pertain to identifying a site that might be suitable for building really almost any kind of a structure. So if you have a few minutes, you can go back and check that out and learn about drainage and retaining walls and that sort of thing. But right now we are finding ourselves up to our eyebrows in putting a roof system on this house. With the ridge beams in place, we can install the rafters. And this is going to go pretty quickly, sort of like when we rolled the floor joists. In fact, that's probably the first thing to point out here. These are called rafters because they're part of the roof system and are installed on a pitch or a slope. If they were horizontal or level, we would call them joists. Now these are almost exactly like our floor joists. They're more of the same wooden I-beam material called BCIs, and they function in the same way. In this case, we're using structural screws to fasten the I-beams through the flanges, into our ridge beams, and into the walls. But to be safe and to comply with the engineer's instructions, we're drilling pilot holes so there's no risk of spreading or splitting any part of that engineered wood flange. The rafters are resting on these beams and the wall, but they are in contact with those thin strips, triangular in cross-section, that I described and installed in the previous episode. In case you missed that, I don't want the weight of these rafters pushing down onto the corner of the beam. We want a lot of bearing to distribute that point load, and that's what we have with these triangular furring strips. Now the lift we did on this part of the project went smoothly. No major problems. But this does not mean that everything was done perfectly. The second big beam that we raised and set in place went right in, dropped in the pockets, looked great. But as I was climbing down the ladder at the end of the day for the last time and glancing back over my shoulder, I noticed that it was too high. And with just a moment's frustrated investigation, I realized that when I figured the lengths of the posts that I put in the gable end wall to hold that beam up, I forgot to subtract the depth of the beam. That 13-inch beam was sitting 13 inches too high. But it's not a huge deal. First, we're jacking up the beam to take the weight off the posts. We're doing this with 2 high lift jacks, which are extremely useful, extremely powerful, and extremely dangerous tools. We have a video explaining how they work. And once the weight is off the post, I'm getting in here with a chainsaw and cutting it down to almost the right location. Then I come back in with this fine saw, this oscillating tool, to really make the top of this post as close to perfectly flat as I can get it. I want the weight of the beam resting evenly across the entire surface of the 6x6 post. Now you notice this spacer? I like to leave a little space to shim the beam up until it comes to exactly the right location, rather than taking a chance on having to cut this post off for the 3rd time. Now altogether it probably took 2 or 3 hours to fix this mistake. lift the beam, cut each post, let the beam back down. And I was not excited when I discovered this mistake. In fact, I was frustrated. And I was low-grade frustrated the entire time I was fixing it. But generally, I'm still on cloud 9. It was a smooth crane day. Everything went into place. It looks like everything else fits. And if this is the worst thing that happened, I'll take it. Now back to the rafters. It's the same story on the main part of our roof, just with a longer rafter, because it's a shallower pitch. These rafters are on the roof that is over our shed dormer. Now you can see why we have 2 ridge beams, one for the actual ridge and one for the top of the dormer. We've set scaffolding up on the 2nd floor, and we're using it to roll around to access the work at the ridge. This is the reason that we did not just go ahead and build the interior partitions up here. We needed the room to work. And scaffolding like this is about 1,000,000 times safer and often faster than using a ladder. But it's still dangerous. You're still up off the ground. And standing on 2 frames with casters, I'm about 11 feet in the air, which was more than enough to do serious damage if I took a tumble. We'll be showing and talking more about scaffolding later on. But for now, we are fastening these rafters the same way we fastened the ones over the garage. A 3 1/4 inch number 10 structural screw through each side of the flange, at each end of the rafter. As you can see, these rafters don't hang out past the edge of the house. They stop flush with the edge of the house. Now normally a rafter would project out beyond the edge of the house, and that's how you create your overhangs or eaves. Now a house doesn't have to have overhangs. Sometimes inexpensive homes will be built with virtually no overhang at all as a way to save cost, and it's certainly not the end of the world. And it can look just fine also, but this house is going to have big overhangs, just like the ones on the gable ends with the corbels, almost 3 feet, both for appearance and for energy efficiency. Now the traditional method of building this roof with this overhang would have been to use a piece of lumber for the rafter that could have cantilevered or extended past the edge of the house to automatically create the overhang, as the name implies. It is the roof overhanging the edge of the house. But you can't very well do this with wooden I-beams because they don't look good exposed, and they don't withstand water at all. And so our next episode is going to show how we solved the problem of overhangs at the eave on this Craftsman-style house. It's something I've never done before, and it's really sort of a hybrid system utilizing sawn lumber and engineered wood products. We're going to be working on this roof system over the next couple of weeks, and it's going to take a few videos to get all of the processes and steps captured and communicated. Now, for the most part, it's basic carpentry work, just cutting lumber, fastening it into position, square, plumb, and true. Unfortunately, it's not really the kind of thing where we can start on one end of the house and work smoothly and consistently to the other end and have it all done all the way as we go. We have a small crew here. There's a lot of work to do, so we're going to have to kind of bounce around a little bit, work on different parts of the roof at different times, bring the whole project up at once, and hope that you'll understand why as we go along. Daniel here is still with us and has turned out to be really solid help, and he's been a good sport while we have these cameras all around the job site as well. This other fellow is Daniel's brother Matt, who's going to help us get this roof put together. Matt has experience working in machine shops and construction. They come from a construction-oriented family, and they learned these things from their dad and from their uncles, and we appreciate their good work as we bring this framing project into its final phase.
Oh, Papa, this would work as a perfect
Thanks for watching Essential Craftsman, and keep up the good work.
Hey, Rusty, say hi, Dada. Rusty. Rusty.
Oh, really?